is now being recorded.
So here is the session. I think maths should be taught using investigations. So this session, my favorite way to design any session is using questions. So it's like, what are investigations? Why should we teachers use them? And then the most important question is, how do we use them? And here I'm bringing a lot of examples from curriculum that, okay, if you're teaching fractions, here is an investigation that you can use. If you're teaching statistics or probability, here is an investigation. Here is technology in use in investigation. And then most importantly, you can learn a new idea, but it is also important to learn what are the skills that I need to implement it. For example, I may get all excited that I'm going to climb the Everest, but I also need to know what are the skills which are needed to climb the Everest. And do I have those? Do I have the health? Do I have the skill to do the financial planning? So I think it would be important to know how do we, what are investigations and how do we use them. But it would also be important to know exactly what are the skills which any teacher needs, what are the skills that students develop when investigations are used, and then one can do a bit of a mapping, do I have these skills or do I need to learn them? And then the learning curve kind of keeps growing. So here we go. I'm going to start with just showing you a small clipping from a primary teacher's classroom in Australia. You may feel this is not directly linked to math, but I would just like you to watch what are the various things that she's doing in the classroom. I will show you maybe for about 2 minutes maximum, and you can watch the rest of it later. And then let's see if anyone would like to talk. I'd love to have a discussion on this.
The beginning of a series of lessons to try to scaffold.
Can you hear?
Hands up and tell me what this word is. Everybody whisper it to me. Predict. I thought you'd know.
So she's starting with English, but she's going to come to math. So anyone who's wondering what is this to do with math, please note.
That. And what does predict mean? So what I did was actually a non-math thing, and I started reading them a story, and it was about predicting. So because I think they've had a lot of experience with reading stories and making predictions and hearing that word predict, that would be a link between that and their maths. Who can predict the story? Sophie?
They might eat all the fish and there'll be no more left.
You think they'll run out of fish? You know what, that's a great prediction. I like that answer. I wanted children to be thinking about prediction, and I wanted them to use some data that they had collected to make predictions that would help them in the next lot of data that they were collecting. So it was a very simple kind of collection of data where they were asked to predict how many blocks or how many objects that they could pick up in their hand. So they had to make the prediction first and then actually pick that up. And how many can you pick up from here? Let's have Lily. How many do you think?
11.
You come and see. See, who thinks Lily could be right?
Can we count them?
If we need to, that's a good idea. 36.
Yeah. So what do you think the teacher is doing and why? I'll just wait for like 5 seconds if anyone would like to speak or write in the chat box. She's asking kids to see, how many can you pick up?
36. Have about 36. So
kids are predicting how many can they pick up, and then they will probably count later. What do you think she is doing here? What kind of a math problem is she giving the children?
Probability.
Probability, okay. Is it a closed-ended problem or an open-ended problem? Does it have a fixed answer or can it be any answer?
No, it will have a fixed answer.
No, suppose I'm picking some blocks in my hand
Yeah.
and I'm guessing how many blocks do I have. Would that be a fixed answer or would that be a
It will not be a fixed answer then. Yeah.
Exactly. So she's giving them an open-ended problem, open-ended answer. Exactly. Thanks, Vinita ma'am. So this is what she's doing. And so I'm going to come to this, what are investigations from this particular video. So NCF 23 says, students should always be performing simple investigations related to specific questions independently or in groups. So what the teacher is doing with the little kids, she's asking them to investigate and pick up certain, like when we were children, my cousin used to do that. You know, he would pick up a lot of stones in his hand and he would say, Didi, how many do I have in my hand? And I would always purposely predict incorrectly, and then he would count and say, you know, you are this wrong or that right. So she asked them to just investigate how good are you in predicting. So can you predict that the answer would be sometime 7 to 9, or are you going to say 19 or 20? So that is something I wanted to show with very small children. Otherwise, in the presentation, I have examples from primary, middle, as well as senior. But as I said before, please, if you want a specific topic that, ma'am, what do we do here? Do let me know. I also have a bunch of resources. So at the end of the session, when you get the PPT, you'll get loads and loads of resources. I think enough investigations for you to use the whole year. So this is what the NCF says. Now, as maths teachers, try and understand problem-solving questions, questions in exercise, investigations are three different things. Let's divide them into the three. I think close to investigations, I would say to some extent, case study questions in CBSE are close to investigations. But still, let me see. Tell me, out of these three, which question is a typical exercise question? This is from Coordinate Geometry, high school. Which question is a bit of a challenging question, so the kids are going to be forced to use problem-solving skills? And which question is a question which is open-ended, so they have to investigate and arrive to an answer? It's obvious also, but tell me, 1, 2, and 3, which one is a typical exercise question? You can unmute and speak, or you can put your answer in the chat box. Which is a typical exercise question out of these, which you see in textbooks? Find the equation of the line through the origin and the given point. Is that an exercise question, or is it slightly more challenging? Another question is find equations of lines through 2, 1. And third is investigate equations of lines intersecting at a common point.
Okay. I feel second one is the typical question, ma'am.
Typical. Okay. What about the first one?
First one, like it is not open-ended.
Yeah.
But it is investigative.
Okay. And what about the third one? Investigate equations of lines intersecting.
It is open-ended.
Open-ended. So
yes.
Actually, first one is a typical exercise question where they say just find the equation of line through origin and given point. So Purabhi, thank you. Your answer is close to what my answer is, but please understand there are no perfect answers here. Every answer is going to be debatable in open-ended spaces. So typical exercise question is find the equation of the line through origin and given point. So you find the slope, you do your formula, and you get the answer. Second one is find equations of all possible lines which pass through 2, 1. So slightly more challenging because you can get more than one answers. And yes, ma'am, thank you. Third one is, and I think the clue is here, investigate equations of lines intersecting at a common point. So here I'm going to tell the children, what is the speciality of equations that all intersect at 2, 1? What can you say about that? So a child will draw a line parallel to x-axis, y-axis, sloping it out, and then seeing, okay, what exactly, and then a kind of a conjecture is built at the end which can be different for different children. So this is what investigation is. And out of the three, it becomes the highest cognitive skill that the children are engaged with. Exercise is the lowest, slightly higher, I would say HOTS kind of questions is next, and then open-ended investigation is the third. So I'll give you another question. Amy picks 3 of these cards and gets a total of 9. Which 3 cards do you think Amy would have picked? It's a very simple question. Which 3 cards would Amy pick? She wants a total of 9. Please, please, maths teachers, jaldi, jaldi. She wants a total of 9. So which 3 cards would she have picked up? 2, 3, 4. Yes, 4, 3, 2. 7, 3, 1 would give 9, Priyanka ma'am. We are adding. Now, this is a simple question. And the kids might say 1, 2, and 6. 2, 3. Yes, ma'am. 6, 2, 1, 2, 3, 4. Children can give these answers. Now, I'm going to make the question a little complex. And the question becomes, can I choose 8 as one of the cards if I want 3 cards and get 9? Will the answer be yes or no? Can I choose 8? No, because I want 3 cards. So I'm going to ask the kids, explain. Why can't I pick 8? Can anyone explain to me? Why can't I take 8 as one of the cards? Janvi ma'am, can you explain? You can unmute and speak, or you can chat. I want 3 cards, total should be 9, but I picked up 8. Why can't I pick up 8?
Because if we pick up 8, so there will be remaining only 1 card. That is 8 plus 1 would be 9. So I can't pick up 3 cards, right? I can pick up only 2 cards for that.
Fantastic. And this is what we engage with. This is what's called math talk, which is going to be my session on next Saturday. You get the kids to give reasoning aloud. Now, can I choose 7 as one of the cards? Yes, no, and along with that, please also give the reason. I want to pick 3 cards. 1 is 7. Can I pick 7? And all the cards can be picked up only once. Can I pick 7? No. Why, Priyanka ma'am? Yeah. Why not, sir?
Because if you pick 7, then you need to 7 plus 2 gives you 9, but there's only one card.
The third card.
Number,
Exactly.
yeah.
Exactly. Now, can I pick 1 and 3 as 2 of the cards? Yes, ma'am. That's correct, Sheetal ma'am. Can I pick 1 and 3 as 2 of the cards? Yes, I can. And what would be the third card if I pick 1 and 3? Yes, that's true. Thank you. Thank you, everyone who's responding. Third card would be 5. So this is what is called a bit of mental gymnastics. Like, gymnastics is an exercise that makes the whole body very supple. So these are the questions in forcing children to think beyond the regular 1 plus 2 is 3 and 3 plus 4 is 7 is what gets them mental gymnastics. So this was another example. So what are mathematical investigations? One is they are a sustained exploration. There is always an element of open-endedness. Open-ended, for those of you who are hearing this for the first time, close-ended is single solution, 2 plus 2, 4. Open-ended is more than one answer is possible. For example, what makes 4? So 0 and 4, 1 and 3, 2 and 2, 6 minus 2, 8 divided by 2. So there can be infinite answer. What makes 4? Or give me 4. So I can give you 4 pencils, 4 sharpeners, 4 fingers. I can give you 4 hugs. That's 4. So that's a bit of open-ended exploration is there. Problem solving is convergent. It has a definite goal. I want to get to the answer. Investigation is divergent. It opens. I want to get to as many solutions as possible. So it's opposite of a textbook exercise question, and very, very much used in, let's say, in ICSE projects. In IB, IGCSE is filled with investigation questions. And CBC also always has one question in the final paper, as I've heard teachers say that, which throws everybody off. Then investigation is different from word problem because there need not be one way of working it out. And you also may need a trial and error. So what I have seen, and I've taught math for 20 years, I've seen that children start thinking math, problem, method, answer. So they become trapped in formula. So bring them out of that box called formula, ask them to do a bit of trial and error, testing, and then coming to an answer. Because life is not governed with formula. Even higher maths is not governed with formula. You need to have a bit of a researcher approach when you do. And that's what bringing investigations in class brings about. Any thoughts coming to anyone's mind here? I can just pause for 10 seconds if anyone would like to say something. So it's like a life skill, giving children a question which is where multiple solutions are possible, multiple methods are possible. No, it may not be asked in the exam, but yes, it is required if you want them to become mathematicians in life. So that's why it is something I would urge everyone to use as much as possible. Now, okay, investigations are great definitions. How do we implement them? So implementing investigations, and I'll show you maybe snippets of classroom video and lots of examples. It's a 3-act work. Start with whole group discussion. Throw a problem at the kids. For example, I can say, get me 4. Or I can say the question that I showed you. What is so special about all the lines that pass through a point 2, 1? That's high school. Middle school, I can say, how many solutions can I have to 2x plus 3y equal to 11? How many of those solutions have both odd numbers? How many of those have even numbers? Then I can also give how many even numbers are there? Is it true that all odd numbers and even number of odd numbers and number of even numbers are same? So first thing is just throw a problem. Second part of classroom structure would be children are sitting in small groups and discussing. And the third part is, let's say first part is 5 minutes. I threw a problem, open-ended discussion. Second part, tell them, now you have 10 minutes to discuss this. And some of you are here from online tutoring, one-on-one tutoring schools also. I think we can now call them also schools because such fantastic teachers are there. I would say start by throwing a problem at the child if you're in a one-on-one class. And tell them, have a little bit of a discussion. Then tell them, okay, you have this much time, maybe 3 minutes or something. If you're in a classroom, kids are working in groups, maybe 10 minutes. And then bring everybody back and say, okay, group 1, what did you find? Group 2, what did you find? And one spokesperson from each group. Try and wind it up in a single lesson. So they get it, everybody responds and everybody else comments on it. And the thing to remember it as a teacher is when the groups are discussing and responding, step back. We are always in a hurry to give answers to the kids. So that's the time to step back and allow the answers from the kids to come up. So here is a group of teachers who tried out investigations, which they might also call it inquiry-based learning because these are overlapping words. And they tried it out, and this is what they said.
I would say before I started doing investigations in my classroom, it was more, I think, teacher-led. And teaching a skill, the kids went off and, would master it, and we would move on.
It was a very digital classroom where I would teach a lesson and then the students would go online and they would work on 10 marks, and it was all digital.
So our students are extremely hands-on with the math program. They're asking each other those how and why questions. They're manipulating things. They're discovering things. It's just a different atmosphere in the classroom where the kids are excited about their problems and how to solve them.
The discussion is a big piece. That's what's changed, I think, drastically in our room, and the excitement for math. When we say, or when we let them know that it's, it's time for math, the kids are much more excited.
My classroom has become a lot more collaborative. There is a lot more math conversation. There's a lot more of students excited to share how they solved a problem and another student jumping in and saying, I did it a different way.
Rather than the teacher posing the question that this is what we're going to learn today, the student ends up through exploration finding out the answer to the question that's posed.
They're in the driver's seat. They're definitely driving the instruction, guiding me on where we need to go next.
It's so amazing to see what they come up with before I can even think that they're ready for that concept. When we throw out a question or when they have a question, they explore it through manipulatives and they come up with solutions, and then they build on each other.
Students realize that there's more than one way to solve a problem. So they're taking strategies that they've learned previously and applying them.
They are thinking so deeply about the process. They're not just reading a problem and solving it. They're really thinking about why they're choosing a certain strategy and how they're doing it.
I think they're gaining a better.
So I'm pausing it here. I just like to hear your thoughts. Is there anything that stood out for you? Any word that the teachers were discussing before and after of the using investigations in the class? So did anything, like one teacher said, after I started using investigations, my class is more collaborative. So similarly, did anything stand out for any one of you? Okay, I'll play it maybe 30 seconds more and just listen, like before and after. What is the change that the teachers are noticing?
Sense of number, as they work through their problem and they share their strategies, and they're becoming exposed to different strategies, that they're getting a better understanding of how numbers work.
And there's also excitement with them when they've only known one strategy and it doesn't work for them. And now they've learned other strategies that do, that they're now able to solve a problem and be successful.
Changing math programs was appropriate for elementary.
Yeah, would anyone like to say something? What is it that the teachers are discovering after they brought in investigations? Okay, let's move. Let's move to some curriculum-based investigations. I will just give you some concept-based examples here. And
Hello.
yeah.
So investigation, what it does is the approach was more, I'm just say student-centric in the way that students could explore more ways of, because the pedagogy was focusing on how to teach and rather than what to teach.
Absolutely.
So that is very, very, very important.
Absolutely. Fantastic. Thank you, sir. And thanks, ma'ams. I think I missed some messages here. Priyanka ma'am says, in this scenario, teachers become facilitator. Absolutely. This is fantastic observation, because anytime you step back, like sir said, classroom becomes learner-centric. The moment a teacher steps back a little and allows kids to learn on their own, they have a sense of numbers, more exposure. That's absolutely true. And that's what investigation does. So let me show you some investigations which are connected with concepts. Investigation using numbers. So let me ask all of you. If 6 plus 4 is equal to 7 plus 3, is 6 minus 4 also 7 minus 3, or is it not? Which one is true and why? Would anyone like to explain? If 6 plus 4 is 7 plus 3, 6 minus 4 also should be 7 minus 3. And please, there are no right or wrong answers. You don't have to use a typical math language. You can just explain it in your own words. For example, I can say, no, 6 plus 4 is 10, 7 plus 3 is 10, 6 minus 4 is 2, 7 minus 3 is 4, and therefore they are not equal. You can give any answer. So this is like an open-ended problem that can be given to the children, and then they can maybe come to the fact that addition is addition. Which math concept do you think this is based on? Would anyone like to guess?
Closure property.
Yeah. So investigation using numbers. Now, investigation using measurement. This is, the link is here, which you can have a look. It's on Desmos, where this is a very typical problem in measurement, that I have a 72-foot roll of fencing and I need to make a rectangular pen for the rabbit. So how can I do that? Can anyone tell me? I need, which concept is this based on? 72-foot roll of fencing is there and I want it to become as big as possible and it should be a rectangle. What is this based on? Yeah.
Mensuration.
Emojis also is a way of responding. Thank you. Yes, sir. Sir, you were saying something, Gyan sir?
It depends on mensuration also.
Mensuration, exactly. So I have the perimeter is 72 and I want the maximum area possible. So children can sit with their graph papers and create a rectangle and see which one is the maximum. Investigation on paper, give children graph paper and tell them, I want you to make polygons with area as 5 square units. And you can make it in any way. So children will make in different ways. And then they can be asked, which one of these has maximum area? Any questions can be asked. Which one of these has minimum area? How can we maximize the area? Can we draw something which has, what is the maximum number of sides it can have? And by the way, all of these examples, the website from where I have taken, they are there in the notes. So when you get the PPT, you can look at the full problem. So this is investigation on paper for maybe grades 5, 6 when you are introducing polygons. You can also then move to convex polygon, concave polygon. Which of the polygons are these where all the lines are inside and which ones where lines are also going outside? So convex, concave polygon, polygons with different sides, squares, rectangles, maximizing area. A lot of discussions can go around it. Investigations in compound interest. Is it true that compound interest of A% per annum for B years is greater or lesser or same as B% for A years? If I give this question to all of you, how do you think you will test it out? I would say test it out. Is the compound interest of A% per annum for B years? What is the relationship between compound interest of B% for A years? How do you think you will test it out? I was just talking to my finance advisor and we were discussing compound interest only. So would anyone like to try it out? If I ask you, all of you maths teachers, that please check if this is true. What will you do? What's the first thing you will do? So I would take an example. So I'm going to put, let's say A is 10 and B is 20. And then I'm going to see, is 10% per annum for 20 years bigger? And I'm going to, let's say, keep the principal as 100. Then I'm going to take another example, maybe smaller or bigger. And then I'm going to take 4 to 5 examples. And then I will come to my conclusion that, yes, it is always greater. No, it is sometimes greater or lesser. So this is what is a very typical investigation question where the children have to actually get together and work it out. This is one of my favorites because vocabulary of math is so important from grades, I think when they start talking till grade 12. and give them all the words that they have learned and ask them, this can also be like a homework. Choose a vocabulary card and draw a picture or write a problem to illustrate it. And if you're working in a group, then you make a card and ask your partner, can you guess what this word is? Anything. So let's say I pick the word volume, and then I have to either draw it or I have to create a problem on volume, and that I give to my partner, and the partner has to guess. But this can also be simply a homework, that choose the vocabulary of this chapter is this, as a homework or a classwork or a formative. Draw a picture and write a problem based on this word, and that's like the homework or the classwork or the formative. Investigations in real life can be really amazing. So this is based in UK, but I think the situation can be translated easily to India. And this is a question that's in my mind, every time I zip out Swiggy or Zomato and I start thinking that let me order coffee, or every time I pass Starbucks or another cafe coffee day, and I look at the prices of coffee and I'm like, 350 rupees for a cup of coffee in Starbucks, 350 rupees. I can buy filter coffee, which will last me for a whole month at home. So should I have, should I not have? So this is investigation which you can give to the children, that a coffee shop sells coffee for this much money. A jar of coffee costs this much. This is how much is needed to make 1 cup. So Mr. Jackson is drinking 3 cups of instant coffee at home, and twice a week he's buying. So suppose he stops having coffee outside. How much money is he saving? And believe me, once I was just Googling how to save money for travel. And so there are some confirmed travelers across the world who save every penny the whole year, and then they take a trip. And one of the things somebody wrote, that I didn't go to a coffee shop for the whole year. And he actually showed how much he saved. So this is like an investigation kids can do, which is from real life. Investigation using fractions, that I'm converting a fraction into a sum of unit fractions. In how many ways can I do it? Charlie has done it in this way. What is the rule he's using? Now, one question for all of you teachers. Do you think you should know the answer when you're giving the investigation to the children? What do you say?
Yes, we should.
You should know. Okay. Should you know all the answers, or should you know maybe 1 or 2 answers? What would you say? You can put it in chat. Okay, ma'am says 1 or 2. Exactly. You should maybe know 1 or 2, but the whole fun of investigation is when you get something really new, which means that there will be that odd child. Like I had a kid called Nilanjan in my class. Not all answers. Thank you, sir. Thanks, ma'am. I had this child called Nilanjan in my class, where every maths class, when I was teaching CBSE, he was in grade 9. Every class I used to wait, let's see what Nilanjan comes up with, because he would come up with something so unique that I wouldn't have thought of. So I used to keep that they amaze you. Thanks, Priyanka ma'am. Their approach sometimes amazes. Like you have in CBSE, the toughest geometry problems I've ever seen, and I've done like CBSE, ICSE, IGIB, the proving questions of CBSE, especially, there used to be a book from NCERT by one Dr. Das. I think it's out of print, and this geometry proving questions were such in it that at times I used to stay up half the night to try and crack it. And I would take it to the class, I would give it to the kids, and Nilanjan would come up with like, you just make 1 line here, and you make 1 line here, and you may construct this line. That's it. The answer is proven. So as Priyanka ma'am said, they may amaze you with their answers. So don't try to get all the answers. If you have, I think, 1 or 2, you're safe. Error analysis is an amazing way to do investigation. That, okay, what do you all say? Is this true? Middle and high school teachers. Is 2 square into 5 square equal to 10 square? Yes, no, maybe? You're very scared to give me answers to math questions.
I
Is this,
believe it's correct.
Right.
is this right? 2 into 5, 2 to the power 2. Okay. Okay. Can you explain why is it correct?
We are using laws of exponents over here.
Okay. Now, one can also always ask them, will it work for all numbers? What if I change exponent to 2, 3, and 2? So, give a question like this, ask them, is it correct, incorrect? What if I change this? What if I change that? Tell them there is an error in this question, figure out the error. So, that is another investigation that can be asked. Okay, before I move to this, any question anyone has, like any concept brewing in anyone's mind that expand? Yes, Sheetal ma'am, thanks. Anything brewing in anyone's mind that how can I do investigation in this topic? Because I've given as many examples as possible during the time that we have. Okay, if you have, you can always ask in the WhatsApp group. So what are the skills which are needed to implement investigation? So kids think math is question, answer. A mindset shift is needed in students. Growth mindset, which is a buzzword in the world, that it's okay to be wrong. That I am wrong, that means I made an effort. When I made an effort, my brain increased. And the lady who brought this whole idea, the idea has come from, I've forgotten the name, but the lady who has brought this into math is Jo Boaler. I'll show you a snippet from her TED talk later. The other is they should feel like detectives. So if you want to make the kids motivated, tell them, okay, you are going to be detectives today and I'm going to give you a situation and you need to figure out whether the situation is solvable, non-solvable. So make it a bit of dramatic. They need to have a problem-solving approach that let's try and solve it. And they need to learn to collaborate. Investigations work wonderfully when kids are collaborating. That collaboration in a classroom is kids with each other, but the collaboration can also be in a one-on-one classroom between child and teacher. So having a dialogue, for example, the slide that I showed you, 2 to the power of 2 into 3 to the power 2 is what's the answer? The teacher can say, no, I think there's an error here. So where do you think it's right? So it requires conversational capacity and collaboration. In teachers, there are some qualities, and here I would like you to analyze yourself and see, do I have this? You should be able to present unfamiliar investigations with very little indication of how to solve them. Like we discussed before, if you know 1 or 2 ways to solve them, you should be, that risk-taking attitude that I don't really know all 20 ways of solving this, but I'm going to show it to the children and let's see if new approaches come. You encourage children to use their own procedures. Now you may say examination expects kids, especially the CBSE, for kids to use only a single method, but exam skill is different from mathematizing skill. So you can tell the children, yes, exam skill is this, but let's also see if there is another way of solving this. So you have that capacity as a teacher where you are open in the class that yes, there are more ways of solving a problem. You are a teacher who poses open-ended problems to the children. You're someone who wants children to explore. So you are not a teacher who will always say x plus 2 equal to 7, so x is 5. You are someone who will probably turn that problem around to something else. And you might say, how can I write a linear equation with 7 on the RHS? Or in how many ways can I have a linear equation which gives me 5 as an answer? So you are someone who loves to create mental gymnastics for the kids and you thoroughly enjoy it. You enjoy getting kids turning into detectives. You encourage children to work in cooperative groups. So there's a school I visited for 2 months, and I saw the whole time teacher is teaching, the kids are all sitting. And I asked her, why don't you try breaking them into groups and working with each other? And it took me a month to get her to accept it, because the whole idea of I must control the class, I know with my own background, it gets very ingrained in us. But you encourage children to work in small groups where you may not be in control of the whole of the class. So I think these are the 4 qualities which must be there in an investigation-based class. And now I have a question for you. Would you like to put in chat box, which of these do you think I have it? A, B, C, D. You can just write A, B, C, D. You can also say A and C, B and D, or A, B, C, D, all 4. If you have all 4, you're already fantastic. You should be conducting a session on investigation-based class yourself. So can I have some answers here? Or you can even use the emoji thumbs up if you think that you are already doing it. Okay, thank you, ma'am. Anyone? A and B, fantastic. Anyone else? B and C, great. B, great. So now you have B and C, so you have A and D to work on. If you have A and B, you have C and D to work on. So, but you can take this like a 4, at least from my side. I'm sure there are more, 4 things that you can take. Thank you. Thank you so much. Thank you so much, sirs and ma'ams. The other thing you would be doing is, you can share this or not share this. We will run short of time, so I'm just showing it to you. So there are teachers who like only one type of problem solving technique to use in the class, and that is my technique. I want you to do it this way, or exam technique. Exam wants you to do this way. But I would say if you're teaching board classes, separate exam skill with mathematization skill, as the position paper of NCERT says. Maths for life is a different skill than maths for exams. So you are someone who is using multiple ways of solving a problem, trial and error. Why don't you draw a diagram to solve it? Why don't you get some data? Why don't you look for patterns? Why don't you let me show you one problem and then you can do another? Why don't you work backwards, like answer is 19, let's get to it. Why don't you circle what's most important in the question? So you have a toolbox of different strategies, a toolbox which is growing. And then you expose children to that toolbox depending on the situation. Then you are definitely like, you're creating mathematicians in the class. So you are like really fantastic in that. So last thing I want to show in this chunk, which is what are the skills needed, is a little bit of a clipping from Joe Waller, who has revolutionized maths teaching and learning by bringing concepts such as growth mindset, visual thinking, investigations, open-ended problems in the world. I'll show you a small bit of it, but this TED Talk is worth watching. Link will be in the PPT.
So this shows us something that brain scientists have known for a long time, that our cognition and what we learn is linked to our beliefs and to our feelings. And this is important for all of us, not just kids in math classrooms. If you go into a difficult situation or a challenging situation and you think to yourself, I can do this, I'm going to do it, and you mess up or fail, your brain will grow and more and react differently than if you go into that situation thinking, I don't think I can do this. So it's really important that we change the messages kids get in classrooms. We know that anybody can grow their brain, and brains are so plastic to learn any level of maths. We have to get this out to kids. They have to know that mistakes are really good. But maths classrooms have to change in a lot of ways. It's not just about changing messages for kids. We have to fundamentally change what happens in classrooms. And we want kids to have a growth mindset, to believe that they can grow and learn anything. But it's very difficult to have a growth mindset in maths if you're constantly given short, closed questions that you get right or wrong. Those questions themselves transmit fixed messages about math, that you can do it or you can't. So we have to open up maths questions so that there's space inside them for learning. And I want to give you an example now. We're actually going to ask you to think about some maths with me. So this is a fairly typical problem that's given out in schools, and I want you to think about it a bit differently. So we have 3 cases of squares. And in case 2, there's more squares than in case 1, and in case 3, there's even more. And often this is given out with the question, how many squares would there be in case 100 or case n? But I want you to think of a different question now. I want you to think without any numbers at all, or without any algebra. I want you to think entirely visually, and I want you to think about, where do you see the extra squares? If there are more squares in case 2 than case 1, where are they? So if we were in a classroom, I'd give you a long time to think about this, but in the interest of time, I'm going to show you some different ways people think about this. And I've given this problem to many different people. And I think it was my undergrads at Stanford who said to me, or one of them said to me, oh, I see it like raindrops, where raindrops come down on the top. So it's like an outer layer that grows new each time. It was also my undergrads who said, oh no, I see it more like a bowling alley. You get an extra row, like a row of Skittles that comes in at the bottom. Very different way of seeing the growth. It was a teacher, I remember, who said to me, it was like a volcano. The center goes up, and then the lava comes out. It was another teacher who said, oh no, it's like the parting of the Red Sea. The shape separates, and there's a duplication with an extra center. And I remember this this one as well. Some people see it as triangles. They see the outside growing as an outside triangle. And then it was a teacher in New Mexico who said to me, oh, it's like Wayne's World. Stairway to heaven, access denied. And then we have this way of seeing it. If you move the squares, which you always can, and you rearrange the shape a bit, you'll see that it actually grows as squares. So this is what I want to illustrate with this question. When it's given out in maths classrooms, and this isn't the worst of questions, it's given out with the question of how many. And kids count. So they'll say in the first case there's 4, in the second there's 9. They might stare at that column of numbers for a long time and say, if you add 1 to the case number each time and square it, then you get the total number of squares. But when we give it to students and teachers, high school teachers, and I'll say to them when they've done this, so why is that squared, do you think? Why do you see that squared function? They'll say, no idea. So this is why it's squared. The function grows as a square, and you see that squaring in the algebraic representation. So when we give these problems to students, we give them the visual question. We ask them how they see it. They have these rich discussions, and they also reach deeper understandings about a really important part of mathematics. So we actually need a revolution in maths classrooms. We need to change a lot of things. And part of the reason we need to change so much is because research on maths teaching and learning is not getting into schools and classrooms. And I'm going to give you a stunning example now. So
I would leave it to you to see the second stunning example. But basically what she's trying to say is that research that talks about open-ended questions should be done is not going into the classroom. Any thoughts here or any reactions from the emojis on listening to Jo Boaler and her experiment and how she changed her question, which is a very typical IGCSE question, on its head? 3 ways of responding: speaking, thank you, Priyanka ma'am, emojis, or chat message. Thank you so much. She's amazing. So with that, I am summing up. We have 5 minutes more for questions. What we have covered are, what are investigations? Why should we use them? How do we use them? What are the skills in play in an investigation class? Now, my favorite question in all the session is, what is the one new thing that you have learned today? That is my question for everyone. Think about it and please, you can. Now, I don't think emoji is going to work. You'll have to either speak or you can put it in the chat box. What is the one new thing that you have learned today? If you have learned multiple things, you can give me multiple things. Meanwhile, I will share the PPT with you.
So, ma'am, I have learned about the types of questions. I was already giving these type of questions, but I learned like the segregated, how it is segregated, open-ended question, investigative, and like typical questions. So that was really like it was really helpful for me. Thank you.
Thank you. Thank you so much. And I have also given you, meanwhile, the PPT in the chat box and the feedback form. If you can fill that, it will be great. It always helps. Every presentation of mine is changing after feedback. So, yes, ma'am, it generally happens most of the time. Teachers would be doing it in the classroom, and with these webinars, they kind of get the language for it, and that's fantastic. Priyanka ma'am says skill set required for investigation. Great. Shita ma'am says A is not always equal to B. That's a great response. Ajay sir says give open-ended questions to the class and help them solve in groups. Yeah. Anything else anyone would like to share? What is the one thing, like, you have given about an hour of your time, so you should go back with something, no? So that's why the question is that what is the one thing that you have taken from this session?
Hello.
Yeah.
So in summary, I feel the investigation are powerful education tools that promote, say, critical thinking, problem-solving skills, creativity, and so on.
Yeah.
So they enhance engagement, prepare students,
Yeah.
and instill a love for learn and discovery. So that's what it's all about.
Yeah. Yeah. That's great. That's great. Anyone else would like to say? Yeah, some people are putting in the chat. Using collaborative learning, researcher approach, encouraging them to use trial and error. Great, great. Anything else, anyone? Any questions, any thoughts finally? Otherwise, we can wind up. Any question, any concept you feel? And the WhatsApp group will continue for about a month. Even if you get, if you need anything, you can even put there. Let's say you're going to teach a concept and you say, can you give us some investigations that I can use here with my class? Please feel free to ask me questions, or you can even ask your colleagues.